Hi everyone. In this lecture, we will see various data exchange patterns in microservices. Throughout our course, our use case will be of an e-commerce application in which after each order placed by the customer, based on its order amount, loyalty points must be updated for him or her. So in our typical microservice architecture, we will be having an order service responsible for managing the orders, and it will have its own database orders DB. Also, we will be having a loyalty service responsible for managing the loyalty points for the customers, and it will have its own database loyalty DB. Now, after each order is placed by the customer, REST API of order service will be called to persist the order details in order DB. And after this, somehow loyalty service must be able to know what are the order details it is interested in. Typically, what is the user ID who is placing this order, and what is the total order amount for this order, so that it can update the loyalty points in the loyalty DB for that customer who has placed this order. For this type of data exchange between microservices, we mainly have two patterns. So first is synchronous data exchange using REST or gRPC, where after persisting the order details in order DB, order service will call REST API of the loyalty service, and this communication or the data exchange will happen in synchronous way. So order service will send the request and will have to wait for the response from the loyalty service. Main advantage of this pattern is that the data exchange is in real time, and hence there are no data inconsistency problems at any given point in time. But the major disadvantage of this approach is, as these are blocking calls, they may affect the performance of the service, as there is a network delays between the API calls. Also, there is tight coupling between the microservices. Developers of order service should know that they need to call the loyalty service after persisting the order details in the order DB, which is kind of unnecessary responsibility on them. Also, tomorrow there might be tens of other services like loyalty service which might be interested in knowing the details of the newly created order. In that scenario, adding 10 other REST calls in order service will make it more complex and also add more network delays and eventually take the hit on the performance of the order service. Also, as these are synchronous calls, every new service call will decrease the total availability of our order service, which is at the heart of our e-commerce application. Also, in case of such microservice call chain, there is a risk of cascading failures, like when loyalty service goes down due to some problem, order service will take the hit, and this should not happen, should not be the case, because we should be able to accept the new orders no matter what is happening with our loyalty service.